All right. Hello and good morning, good afternoon, good evening to everybody that's joining us today. My name is Samantha from Safeopedia, and here at Safeopedia, it is our mission to support you, our EHS professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I want to give you a huge shout out for keeping our workplaces safe on a daily basis. Without you, none of this would be possible. So thanks again for keeping us all safe. Today, we are proud to present Soup to Nuts Gas Detection for the Food and Beverage Industry. The Safeopedia webinar has been made possible today by GFG Instrumentation Inc., a preferred manufacturer member of AD Safety Network. AD, together we win. It is my pleasure to welcome back Bob Henderson, president of GFG Instrumentation Inc. Today, Bob is going to examine the common challenges of maintaining a gas detection program within the food and beverage industry, including managing compliance, personnel, and products. With that, I'm very excited to have Bob jump into it. All right, Bob, let's take it away.
Thank you very much for the intro, Samantha. Good morning or afternoon, depending on where you are, and welcome to today's webinar on issues related to gas detection for the food and beverage industry. It's a big topic. It's a short 1-hour presentation. This comprises a get started discussion for those who haven't been thinking about these issues for a while, but that's the idea. We're going to spend a lot of time focusing on whether the instruments that you're currently using, and if you're thinking about expanding or changing your instruments to a new design, how to ensure that those instruments are fit for purpose. There is nothing worse than having an instrument that simply doesn't work because it's the wrong instrument. And a lot of what we're talking about is to ensure that any decisions you make wind up with the right instrument that is fit for purpose. It's a very important consideration. So this next 1 hour, we'll be talking about questions that you should ask, self-assessment questions that you should ask as you are going through your current policies, procedures, and how you're using your gas detection equipment, and what you want to get out of it or change if you go to a new design in the future. In the food and beverage industry, you have all sorts of different gas detection monitoring issues and requirements. You have safety, hygiene, facilities protection, production, process control. Managers need to anticipate critical requirements ahead of time, and you don't want to be dealing with issues after an accident occurs. It's really important to assess your strengths and weaknesses and gaps in your instrument coverage and usage. You want to do that before the event, not after the event. You need to think about whether you are currently meeting all requirements, because requirements change, they evolve. Where do you need to make improvements? Gas detection issues are not necessarily limited to safety. Toxic exposure limits are getting lower every year. Things that were not an issue in the past can become an issue going forward. Food and beverage safety managers just deal with a whole bunch of issues. If you're working at or working with a large facility, often they're the size of a small city. The picture at the in the 2 o'clock position is a large meat packing plant in Kansas. That's as big as any industrial mill that I can think of. And it has as many confined space and process issues as any other kind of large industrial facility. If you're talking about what kind of hazards you get into at a meat packing plant, sometimes it's a little bit surprising. For instance, when you go to pick up a steak at the local supermarket, you'll notice that it is a very attractive, appetizing, bright red color. Well, the way that you get that is when you're packing the meat, you fill the package under the clear wrapper with carbon monoxide. Carbon monoxide on that meat in the steak has the same effect as it does on the hemoglobin molecules in your blood supply. A firefighter who has been exposed to a bunch of carbon monoxide fighting a blaze and comes out will often be cherry red. He's also a lot more prone to having a heart attack or a stroke under the circumstances, which takes a heavy toll of firefighters. Hopefully, he'll be using an SCBA and avoid that. But anyway, um, once the hemoglobin molecules, whether it's in a steak or in a firefighter, are loaded up with hemoglobin, it tends to stay there. And it's the loaded molecules of hemoglobin that give the steak that beautiful rosy red color. The main point here is that kind of surprisingly, you're dealing sometimes with carbon monoxide as a process gas. You wouldn't necessarily think so. With the flash freezing line for chickens in the lower picture, here the problem is ammonia. There is the issue of toxic exposure level of ammonia. There is also the issue of if you have a major ammonia leak, um, you have the possibility of a combustible explosive atmosphere. So that's why ammonia is a particularly dangerous process material to work with. There are a lot of restrictions and regulations that govern the use of ammonia in large scale refrigeration systems, but you're going to have to deal with it and you're going to have to measure it in places where it can escape or accumulate. You also have hazmat and emergency response issues. In all of these places, you have hot work and confined space entry situations. In fact, confined space entry is a near continuous condition in a lot of food processing applications. What are the most common atmospheric hazards? Well, first and foremost, oxygen deficiency. You're dealing with so many situations, applications, and environments where you can develop an oxygen deficiency, often by means of displacement, but also by means of microbial action, processes like fermentation. So you have oxygen deficiency, you have specific gases that are often a consequence of the process in the area, like fermentation. The gases can include CO2, or sometimes, for instance, if you're in the winemaking business, you're harvesting the grapes, you're pressing the grapes. The grapes have been often treated with sulfur to retard spoilage and fungal growth. The sulfur content is great at giving anaerobic bacteria that produce H2S something to chew on. And you have, if you have accumulated the pressed grape organic material, the must, you have a good source, a potential source of H2S. So H2S can be a big issue. SO2, carbon monoxide, ammonia, chlorine. A lot of times we're disinfecting produce with the use of chlorine solutions. Very common. If you have chlorine in the working workplace environment, you have a very low exposure limit to contend with. So you probably should consider measuring the concentration in the atmosphere. You have a lot of combustible gases and vapors that can be associated with the process or the facility. If you're making grain alcohol, then of course you have ethanol, grain alcohol to worry about. But you also have a lot of natural gas. There's a lot of heating, a lot of boiling, a lot of cooking. You have methane, of course, the major component in natural gas. And then you also often have the presence of solvents and other potentially combustible vapor. Typically, you're going to be mostly using a four gas instrument with LEL, O2, CO, and H2S sensors, but often it takes a fifth sensor or specialized sensors to detect the gases that you actually are encountering at your facility. So while most instruments are four gas, an increasing number are set up for five gas or six gas measurement, where the fifth sensor is sometimes it's a photoionization detector for measuring VOCs, sometimes it's chlorine, sometimes it's a CO2 sensor. It can go in a lot of different directions depending on your facility and your applications. And these instruments are definitely not limited. The tools that you use to keep your workers safe in the facility, the tools are not limited to portable instruments. Often, the best approach is to install a fixed detection system, which is a sentry system that operates 24 hours a day. In the food and beverage industry, a lot of the time, if you have a hazard one day, you're going to find the same hazard in the same place on successive days or at similar points during the production process. So the hazards tend to be often very predictable on an area-specific basis. When the hazards are chronically present or present in predictable areas, fixed detection systems should definitely be considered. If the presence of the dangerous atmospheric conditions is associated with a specific activity, like confined space entry, where the procedures are strictly governed by a permit and workplace procedure, then basing the response on portable instruments is a little bit more sensible. Sometimes the best approach is a combination of the two techniques: portable instruments for individual workers or teams, plus fixed detection systems for the area in general. It's certainly not a mutually exclusive choice. And don't be afraid of considering fixed gas detection systems. Many times, in fact, a majority of times, what needs to be done is to add a very small localized system that handles the hazards in the exact areas where they exist. And this can be actually pretty easily done. You can have a system that has one sensor or two sensors or four sensors. The sensors are mounted in small enclosures where you need to take the measurements. The sensors are hooked up usually by a hardwired connection with a controller or a computer where we display the readings and the status of the system, and where we control peripheral devices like alarms and lights and fans. And it's pretty darn easy to install. It's pretty darn easy to specify. At the other end of the spectrum, you can have very large systems with hundreds of points. It does not need to be intimidating. Your friends at AD, the distributors that you work with on a daily basis are trained. They understand the issues, they can provide guidance, they can help you walk through the alternatives. And of course, the manufacturers, that's what we're here to do. Um, and before you go too far down the trail of specifying a fixed gas detection system, make sure you do understand your own company's attitude towards that. Are the fixed system uh, decisions made at a corporate level? Do you depend on a third-party design firm to come up with a guidance and a specification? Who's going to be involved in that process? Also, remember that once the system is installed, that's not the end of the story. You have to maintain, calibrate, test, and periodically ensure that the system is still operating the way it's supposed to operate. So that is to say, make sure you consider who is going to be responsible for periodic calibration and routine maintenance. If it's you, make sure that training is provided by the manufacturer or the vendor. If it's a third party, make sure that you think about who that is and that they are the right choice and an affordable choice. And a lot of these issues can be very easily addressed very early in the specification process by filling out a simple form. All of the fixed system manufacturers have a simple form that asks a few basic questions that they need to have answered before they can provide a potential solution for you. This happens to be the questionnaire that we use at GFG, but the sort of things that you need to find out are always going to be the same, no matter which manufacturer your fixed detection systems that you're talking to. We're going to want to know, do you want to wire it up individually for each sensor, going back by a 4 to 20 milliamp industry standard hardwired connection to the controller or PLC or computer? Or do you want to digitally integrate the system using Modbus or HART or LawnWorks or some other digital communication protocol? Are there interfering contaminants that can mess up the performance of the sensors? Do you have a PLC that you want to use? Do you need a controller supplied by the manufacturer? These are not highly technical questions. They're pretty basic questions. And if you just go through the simple questionnaire, now you're going to get a quote or a suggestion for a solution that makes sense. And you should have a certain level of a minimum vocabulary level. Um, Typically, the system is comprised of a few kinds of components and assembly. You have the actual sensor, which you can see sticking out through the bottom of the sensor transmitter housing. That's where the detection reaction occurs. The transmitter is the local electronics that houses the sensor and powers the sensor and processes the signal. The kind of transmitters that you wind up specifying depend on the type of sensor and the application. If it is what we call an ordinary location where you don't have the potential presence of combustible gas, then the transmitter does not have to be explosion proof or flame proof or intrinsically safe. If the area where the sensor is going to be located is characterized by the presence of combustible gas, then you have to use a design that cannot be a source of ignition in that area. And you can do that by containing the energy within a fairly massive metal explosion proof or flame proof housing, or you can go with a design that is low power, intrinsically safe, and no matter what you do, you cannot harm the sensor in a way that will release or harm the wiring in a way that will release enough energy to be the source of combustion. So just like your portable instruments are intrinsically safe, you can do the same thing with fixed system transmitters. The options go even further than that. You can put sensors out on a cable back to the transmitter, and then from the transmitter back to the controller. Or you can plug it in or terminate it to power, and you're done. You have a standalone system. You can also do things to process the gas before it comes to the sensors. Sometimes a gas that is not electrochemically detectable can be made detectable by pyrolyzing it or oxidizing it to turn it into smaller detectable molecules. We do that a lot with gases like nitrogen trifluoride or carbon disulfide. We run it through the pyrolyzer unit, and what comes out are nice, easily detected molecules of HCl or HF, all of which are nasty molecules but easily detected. For the fixed system controllers, these are the brains of the system. You can use a computer for this function. You can use something called a programmable logic controller, which is a dedicated computerized control system on steroids. They tend to take a lot of programming to operate, but they are capable of running an entire facility from one control room. It's pretty impressive when you see what you can get done with a PLC. Sometimes you need both a local controller and you need the controller to communicate with the PLC. You can do anything that you want, and you're going to need a little bit of guidance for some of these bigger systems. The controllers are where you activate alarms, you trip relays, you turn process control equipment off and on, you actuate fans, you activate auto dialers and notification systems. It's all controlled ultimately with relays in the controller. You program the controller what you want it to do under specific circumstances. These are really quite sophisticated. They can be very easy to operate, menu driven, simple to set up and program, but what they're capable of doing is pretty amazing. I've been in the gas detection business for about coming on 45 years, and it is amazing how the evolution that has gone on over that period of time with controllers and what we're able to do. This innocent little compact DIN rail box is actually, DIN rail is the industry standard mount that you use for the electronic equipment, whether it's fire or temperature or smoke or gas detection. You'll have a cabinet somewhere with what looks like rows of small HO-sized model railroad track, and that's called DIN rail. And this would be a controller that's designed to mount to one of those standard railroad tracks. And in this case, this little 8-inch long device is capable of controlling up to 128 points or transmitters where you're obtaining a sample of gas. And that's pretty amazing. And from here, you can go anywhere else that you want to go. On the fixed and portable side, there has been an amazing proliferation of sensors and detection technologies. The list of detectable gases with GFG, our list is over 500 different explosive and toxic gases and vapors. And in some cases, we use a broad response sensor, like a combustible sensor, because we're not so much interested in what exactly the molecule is. We're interested primarily in how close the atmosphere is to being combustible and having an explosion. Sometimes the sensors need to be highly substance specific. The lower the exposure limit, the more specific the sensor needs to be. So when, for instance, we're measuring ammonia, we don't want to be confused by anything else. We want that reading to be exactly and only for ammonia. One of the things that makes it is a very desirable characteristic is to choose a design that has a smart sensor approach where you can change the kind of sensors or replace sensors by simply plugging them in. The less that you need to do with a soldering iron, the better. The less you need to do with programming, the better. Our approach is you pull out the old sensor, you plug in the new sensor, and you're done. So that's one of the benefits that you have with a smart sensor design. And we're not the only company that takes that approach. It's a good approach. One of the things that you should investigate is what kind of reputation your supplier has with regards to the performance of their sensors. For that, I would start with talking to your local AD supplier. They deal with more than one manufacturer. They know the industry. They know performance. Most of the time, you'll find that they've been in the business for years and years, so they have a lot of experience with these issues, and they can tell you a little bit about how the customers of their equipment have fared in the past. But not all electrochemical sensors are created equal. We're pretty proud of ours. We control the technology. We base our sensors on proprietary designs. They have very long lives. The longer the life of the sensor, the more affordable the sensor becomes. You don't really want to need to exchange or replace a sensor after 1 year. If you can find a sensor that is accurate and dependable and lasts for 3 or 4 years, you're a whole lot better off. So the length of life of the sensor, the specificity of the sensor, the durability of the sensor, all of these issues are important. Some of these issues, you're well served if you go to the manufacturer internet site and look at data sheets. I love reading data sheets, but that's kind of my job. I like writing them too. That's not everyone's cup of tea, but um, grit your teeth and do it. You'll be doing yourself a favor. The more research that you do, the less likely it is that you'll come to the wrong conclusion and have a product that ultimately doesn't work the way you would like it to work. So, how do all these dangerous atmospherics get there? Well, it can be due to materials used in production. For instance, if you're, there's two ways to go with the casings of your breakfast sausage or that tasty hot dog. You can you can create them with the help of Babe the Pig, or you can have better living through chemistry and use a casing that is made from non-organic materials or materials that are highly industrial in nature. One of the things that is a bit of a surprise is the use of carbon disulfide, which is a dangerously explosive and very toxic gas. You also find it in semiconductor manufacturing, but it's one of those gases that you run into during hot dog and sausage production, or it might be. Sodium metabisulfite is used to retard oxidation and spoilage. It's very widely used. If the sodium metabisulfide becomes acidified or exposed to acidic materials, it tends to produce a lot of sulfur dioxide, which is pretty toxic. So you also have chlorine, you have SO2, refrigeration gases, including ammonia, propane, freons, halocarbons. Sometimes this is another one where often for freon leakage and refrigerant leakage, that tends to be most often a fixed system application. So if you have these materials in service in your fire suppression system, make sure that you have a system that will pick up on the fact if you have a leak. You also have chemical reactions going on. You have curing and drying that can use toxic materials. Um, for instance, if you're smoking meat, you need to do something about the smoke itself, which you don't want your workers getting smoked. You want the smoking limited to the ham and bacon. Um, Controlled atmosphere storing is a really big deal in the fruit industry. Here, what we do is have warehouses or storage rooms where we create an inert atmosphere that puts the fruit to sleep. They stop ripening. If you have never thought about it, um, when you're biting into that tasty, crisp apple, it's actually still the tissue itself in the apple is still alive. It's still metabolizing. As it ripens, one apple is talking to another through chemical triggers. As an apple starts to ripen, it starts to produce a little ethylene. As nearby apples encounter that ethylene, they start to ripen and produce more ethylene themselves. So there is a feedback mechanism that winds up with most of the apples ripening on the tree at kind of sort of the same time. Well, if you want to store apples for a long period of time, you want to shut that down. So what you do is you might filter the air to remove any naturally produced ethylene to retard ripening, or you can add ethylene to speed the ripening up. Food transport vessels, marine food transport vessels, are amazingly good at timing the ripening of the fruit in transit so that when it reaches port and it's offloaded, it is at exactly the correct stage of ripeness so that by the time it hits the supermarket, the shopper has an apple that or a tomato or a banana or anything else that needs to ripen to a precise level before being sold. Um, Everything is a matter of timing. And a lot of it has to do with the concentration of ethylene, but also what they will do is to flood the environment with an inerting gas, lowering the oxygen down to 2%. And very sadly, there are many confined space accidents that have been caused by people entering a warehouse, an apple storage warehouse, including, unfortunately, children, after an apple, and they go in and they drop, and that's the end. Um, Here's an example, sadly, from this last year, May 15, 2024, in Wenatchee, Washington, where a worker was assigned to use a fogging device to treat the apples, and that's another thing that you're doing. You're adding chemicals to the apple to make them more physically attractive, to avoid the apple's skin being oxidized and looking ugly, because everybody likes a pretty apple more than they like a splotchy apple. Uh, Reminds me of high school. Nobody liked me. I was a splotchy kid. Anyway, uh, the point is that we treat apples to make them cosmetically attractive, and be choosable from the supermarket shelf. So this worker was assigned to use the fogging equipment to apply the mist, to the chemical mist, to the apples in this storage room. He had a perfectly good oxygen meter, which he hung on the outside of the storage room. And I want to make sure that that happens not to be a GFG instrument. It is a very good Dreger brand oxygen meter. The point is that the best instrument in the world can't do a darn thing if it's not in use. The worker entered that little space and he was overcome by an oxygen deficiency because there was no oxygen in there. The room had been inerted. There was about 2%. Another one of my favorite examples of chemicals in the fruit industry, I love bananas. And fortunately, at least in North America, I have never run into one of these bad boys. That is a wandering banana spider. And you don't want those creeping amongst the bananas on the supermarket shelf. So as the bananas are harvested, they're getting a wash with chlorine water in an aqueous solution. But for shipment, they're being treated often with something called sulfuryl fluoride, SO2F2, which has a really low exposure limit. And you definitely need to measure it. It's pretty easy to measure, but you have to measure it using an instrument that is equipped with sensors for the detection of fumigants. So some of the other common fumigants, methyl bromide is still being used here and there. Ethyl formate is a less problematic fumigant that's replacing methyl bromide, but all of these are not good for people. Phosphine is another. There are sensors available for the direct measurement of all of these chemicals, but you have to invest in the instrument and use the instrument. Another one of my favorite chemicals that I run into all the time is sodium metabisulfite. As I mentioned before, it's used very widely in a lot of different industries, food production application, especially seafood, where just like the apples need to be cosmetically attractive, the same goes and then some for shrimp. Nobody likes a shrimp that has turned black and green, even if it's not rotten, I'm not going to buy it if it looks like it has leprosy. So we have, when the shrimp is caught, it goes through, even before it leaves the boat, one of the first things that it is going to do is go through a quick bath in a sodium metabisulfite solution that actually uh, stops the cells in the shell and skin of the shrimp from continuing to metabolize. Now, the shrimp is dead, but the cells are not dead. They're still metabolizing, and it's that metabolic process that causes the darkening. That's not really rot. Um, Even if it's unattractive, it's not harmful. But that doesn't matter if nobody buys the shrimp. They wind up in the waste bin. So they go through the sodium metabisulfite dip. When they get to the dock, generally they're going to get another rinse with an aqueous chlorine solution, and then they're going to go back into the ice and onto the skewer in your shrimp cocktail. But in this case, there was a very close call accident on a shrimp trawler where they had a failure of their air conditioning system. They had a hold full of freshly caught shrimp. The shrimp had been through the shrimp dip. They were in the hold, but the air conditioning died. And this being in the Gulf of America, uh, this particular accident, the shrimp rapidly rotted in the hot sun. So they got the boat back to the dock. They removed the shrimp successfully. They had a marine chemist sample the air in the hold after the shrimp had been removed. Everything looked good. The chemist went away. The guys came back to re-enter the hold, and two of the ship's personnel were overcome. They lost consciousness. Fortunately, they were rescued, so they did not die. Initially, the thought was, well, maybe it was H2S, because when the chemist came back, they did a little more looking. They removed a plate from the bottom of the hold, and they found a void underneath the plate where the dead shrimp had not been removed, and that's where the rotting was going on that led to the dangerous atmosphere in the hold. But the chemist realized that no, it just does not look like H2S. They actually were seeing a small reading on their H2S sensor in their multi-gas instruments, but the chemist just was unconvinced. He thought that what had happened was the sodium metabisulfite had reacted and released a bunch of SO2. So they came back with an SO2 instrument, and now they found what was going on, and the SO2 concentration was very high. But what was a surprise to everyone, except the people at GFG who'd written the owner's manual, where one of the pages towards the back of the manual talks about interferences and cross sensitivity of the H2S sensor to other gases like SO2, and it was completely understood in the manual that you had about a 5% interference with SO2. If you want to measure SO2, you need an SO2 sensor. So the answer in this case was to add an SO2 sensor to the instruments that they had in service. And now, instead of only seeing a reading for for H2S, they're seeing a reading for SO2 as well. And hopefully the shrimp do not go purple and dark and black like my ugly shrimp there in the illustration. Don't forget that confined space accidents are not only caused by atmospheric hazards. So GFG is a gas detection company. We're mostly interested in gas and atmospheric issues, but there are just way too many confined space accidents that occur almost every day. In fact, it is every day. Just yesterday, I'm a member of the AIHA Confined Spaces Committee, and any member of the committee is keeping track of confined space accidents in their area. When we hear about something, we share the information. Just yesterday, there was a worker killed in a confined space accident. He fell into a pit at the Gateway Tunnel Project in the New York City area. Somewhere, even as we speak, there is a worker who is near to getting killed or will be killed before the end of the day. It's way too often that this continues to happen. These two incidents, Tina's Burritos in the Los Angeles area, was unfortunately cleaning the inside of a very large food processor. An improper lockout tagout allowed the equipment to be energized, and the worker was killed in an unbelievably gruesome way. One of the worst confined space accidents I've heard about in a long time occurred in a very large walk-in oven at a Walmart in Halifax, Nova Scotia, where a young lady walked into an oven, the door swung shut, there was no mechanism to allow her to self-rescue. The oven came on, and she was burned to death. Absolutely unbelievably horrible. Her mother was employed at the same facility. It was terrible. And both type confined space accidents, all three, including the fall, are easily avoided by the use of proper techniques and proper equipment. What are some beverage-related issues and applications? Well, we're talking here about breweries, wineries, distilleries. Sometimes the hazards are associated with fermentation. Other times the hazards go along with storage areas. You have soft drink and bottling plants where you're adding carbon dioxide, you're adding the fizz to the beverage. You have issues at distribution centers involving refrigeration, involving exhaust gases from vehicles that are used to do the transportation or move material around within the warehouse. There's a lot of sources of atmospheric contaminants. Breweries and wineries and distilleries, you've got confined spaces. The whole facility is geared around creating products by means of fermentation, which is a form of microbial action. It's conversion of sugar molecules into alcohol and carbon dioxide. You get as many carbon dioxide molecules out of the mash as you do molecules of ethanol. You have sanitizing and disinfective procedures. You have additives like sulfites, the kinds of hazards that you very commonly run into. Number one, top of the hit parade is going to be carbon dioxide. And then, of course, the alcohol itself is a toxic gas. It's also a potentially combustible gas. And chlorine, especially in disinfecting, is widely used. Sometimes they're using other disinfectants, and you'll maybe need to measure those. And you run into a surprising amount of H2S, especially with wineries where the grapes have been treated by sulfur or where you're deliberately adding sulfites to the wine after fermentation. What is fermentation? It's the process that takes the sugars in the grape juice and or the sugars in the mash and turns them into ethanol. The reaction is one molecule of sugar. Here's your sugar molecule. Here's your sugar molecule. As the yeast digests that molecule, you're getting two molecules of ethyl alcohol, ethanol, and two molecules of carbon dioxide. Carbon dioxide is a toxic gas as well as a displacing gas. So you have more than one hazard when you have the production of carbon dioxide. Ethanol can be hard on your sensors from a couple of standpoints. Ethanol is corrosive, so it tends to erode the little beads in a catalytic sensor that are used to oxidize and detect the combustible gas. So the more alcohol they see, the shorter their lives, and they just suffer a little bit of harm and loss of sensitivity in a fairly brief period of time. Whereas if you were only using the catalytic LEL sensor for methane, it'll last for years. For ethanol, it might need to be replaced after a year or two. Carbon dioxide, colorless, odorless, heavy. It accumulates as the yeast microbes are producing it in a confined space. It just accumulates and it reaches ever higher levels. And it is toxic. The toxic exposure limit is only 5,000 ppm. 40,000 ppm is immediately dangerous to life and health. For ethanol, we like to measure it at ppm ranges with a photoionization detector. At LEL ranges, instead of using a catalytic LEL sensor, we like to use an infrared LEL sensor that cannot be harmed by exposure to the ethanol. There are a lot of new developments in gas detection. Once again, talk to your AD partner. They know what's new on the market. They can take you through the alternatives. If you want to make a change, they can help facilitate that change. Many of your AD partners also can help with after the sale service and support. Many AD distributors have factory authorized service centers. If you'd like some help, it's easily available. You just have to ask. Try not to get lost in price until you've really thought through your needs. Making decisions solely exclusively on price might miss the boat. Eventually, you need to buy something that is affordable, but there is a difference between the cost of ownership of the product and the cost of using that product over the life of the instrument and the initial purchase price. Sometimes a low purchase price, well, I still use my disposable Gillette razor, where the cost of the razor is now ridiculously cheap. They pretty much throw it in for free. You get a few of the razor cassettes. When you go to replace the cassette, when you buy another little tray of cassettes, you find that the cassettes are a lot more expensive than the complete razor was when you bought it initially. That's one approach that some manufacturers take with the sensors, not GFG, as it turns out. We want to keep our instruments in service as long as we possibly can, so we make replacing sensors easy and as affordable as possible. Another approach is just to take the razor approach and um, encourage customers to throw the instrument away rather than replace the sensors, because the sensors are more expensive. These are things that I'm not even saying that that's the wrong approach. Yes, I am. I do think it's the wrong approach, but that's up to the manufacturer and the manufacturer's customers. The thing is, it's one of the issues that you should look into before purchase, not after the fact. You don't want to blunder into expenses that you have not anticipated. So identify those cost of ownership issues. If an instrument is costing a fortune to keep in service, well, maybe it's time for a change. Make sure that you understand what's good about the instruments you're currently using and what's bad. If you are having your subordinates use the instruments, make sure to get their opinions. Debrief them. How's it going? What do you like about the product? What do you dislike? Are there any urgent problems that need to be addressed? Do you trust your gas detectors? Do you feel like you're currently getting a good deal? And make sure you think through who it is that's going to look after your instruments, whether fixed or portable, after you buy them. Is that going to be you? Are you going to farm that out to a third party? Are you going to have um, a remote service that sends you email messages when you need help or time to buy more calibration gas? Um, or are you going to work with your local AD distributor for those issues? You've got some decisions to make. So when you're thinking about updating an instrument, these are really, or purchasing a new instrument, these are really good things to ask. Also, if you're happy with your current instruments, make sure that you talk to the manufacturer. Manufacturers have programs to update or keep instruments in service. They may have a trade-in program, and it may be very easy to add a sensor to existing instruments if you need to measure something else. You might not need to trade in the whole instrument. It's worth having a dialogue with your suppliers. So you've got a couple of friends out there. You have your local distributor. You also have the manufacturer to ask for advice. And remember, the world is becoming not less toxic, we're becoming more and more aware of toxic hazards, and that increases the need to measure additional chemicals like benzene, hydrogen, NO2. Um, Another very important thing to consider if you're using instruments for confined space entry is how do you sample the atmosphere before you go in? Do you have a built-in pump? Do you have an attachable pump? Do you have a pump that you can turn on and off? If you're using instruments for confined space, you have to sample before you go in. Also, you should consider the type of rechargeable batteries that you have in the instrument. Nowadays, everyone hears about another lithium-ion battery fire every day or two. So lithium-ion batteries are full of a combustible liquid. If they develop a short, you can have what is called thermal runaway that leads to a battery fire. You can avoid that if you use a different battery technology. We don't really like lithium-ion batteries. We prefer nickel metal hydride batteries because they are not hazmats, or alkaline batteries, which are not hazmats, but these are, again, things you should consider. If you are going to promote doing a bump check before each day's use, which is recommended by everybody, by OSHA, by corporate safety managers, by the manufacturers of the gas detection instruments. If you're going to require a daily bump test, then make sure that you have the bump test kits or the docking stations with the instruments so that can happen. If you're thinking about wireless communication, make sure you understand the method used by the gas detection manufacturer for wireless communication and think through what you're going to do with that real-time information. Maybe it makes sense, maybe it doesn't make sense. It can be an expensive add-on luxury, or it could be something that you absolutely cannot live without, but you should think it through before you make a decision. And when it comes to buying an instrument or using an instrument, there is the phase before you purchase the instrument where you're making a decision about fitness for use and what you truly need. And now, after you have the instrument, you deserve after the sale support. You deserve someone who is able to help you with training, with maintenance, with whatever you need to keep those instruments in service. So these, again, are things that you should think about. After the sale support is just as important as all the questions that we've been through for self-assessment before the sale. And if you're interested in GFG, we hope that not only will you talk to your local AD supplier, your local partners in safety, we hope you'll visit the internet site where we have all of these materials to support you. We have videos, manuals, application notes, good advice on gas detection selection. We're here to help you, and call us up anytime. It would be our pleasure. And thank you very much for coming into the webinar. I really appreciate it. Bye-bye.
Well, Bob, that was incredibly informative. Some would say maybe too informative, depending on where they are at with their lunch break. Well, a huge thank you to you, Bob. You're always a wealth of information, and we always really appreciate these webinars. So thank you so much. I'm very thankful I'm allergic to bananas, just in case. So again, I want to give GFG Instrumentation Inc. as well as AD Safety Network a huge shout out for allowing you to be here today. Of course, Bob, thank you again. And all of our attendees and all of our dedicated safety professionals, because without them, none of this would be possible. So thanks again. Take care, stay safe, and reach out to Bob. Bye, everyone.
Bye-bye. Enjoy those bananas.